Hello, Algebra 1 students. Hope you guys are doing well. We are moving on to Unit 3, Target 3, and this is called What Does a Function Say? And that title will make a little bit more sense when you watch Mr. Dahl's videos, of course. So we're going to be learning about functions today. A function is a relation, which is a list of ordered pairs, as we can recall, in which each element of the domain is paired with exactly one element of the range. But what does that really mean? Well, first of all, let's refresh our memory of what domain and range are. So we're going to look at this relation, which is, again, a list of ordered pairs, and we're going to determine the domain and the range. So what are the domain and the range? So let's get a little bit of a refresher. What is the domain? That's right. The domain are the x values, and the range are the y values. Okay, so let's start with the domain. So we're looking for the x values in this relation. So we have 3, 5, -4, 8, and 13. So I'm going to list those in order from least to greatest. So -4, 3, 5, 8, and 13. So those are all of my x values. For my range, I'm now going to use the y values. So my y values are 6, 7, 11, 9, and 7. Looks like I have 2 7s, so I'm just not going to list those repeated numbers. So we'll start with 6, then 7, then 9, and 11. Okay, so domain x values, the range, the y values. But what does this have to do with functions? A set of ordered pairs where each x value is put in an ordered pair with only one y value. Okay, so what does that mean? In order to know if a relation is a function, if we're given a finite relation, we're going to look at the ordered pairs and we would look for repeats in the domain. What does that mean? Basically, what this means is that if there are, repeats in the domain, then that means that an x value is put in an ordered pair with more than one y value. See, the key to being a function is this, is that an x and a y value can only be paired with one x value and one y value. You can't have two different y values for a given x value. So in this part of the definition of a function, it must be paired with only one y value, okay? You can kind of consider x and y to be in a relationship, okay? And x and y are dating. Now, would it be bad if x started dating more than one y value? Yes, that'd be cheating, okay? That can't happen. So the key is that x can be only with one y value, not more than one, or else it's like he's cheating and then it's bad. Okay, so let's take a look at our first relations function. So in order to be able to tell if this is a function, I want to look at the domain values. So we have 3, 5, 7, and 8. Are there any repeats in the domain? No. So since there are no repeats in the domain, is this relation a function? Yes. Each x value is paired with exactly one y value. Okay, let's take a look at our second example. So we look at our domain values. We have 0, 1, 2, 3. No repeats. So is this a function? Yes. Same reasoning. Each x value has its own y value. Okay, taking a look at the third example, we have 5, 3, 4, 6. So would that be a function? Do we have any repeats in the domain? No, we do not. So the exact same reasoning. Each x value is paired with exactly one y value. Okay. And this last example, so we're looking at our domain. We're looking for repeats in the domain. We have 0.3, 0.4, 0.3, and 0.5. We have our first repeat. So would this be a function? No. The x value of 0.3 is paired with more than one y value. So what if we are given an equation or a graph of solutions that contains an infinite number of ordered pairs? So I'm talking about something that looks like this, the graph that's on the bottom left of your screen there. Would this graph below have any x coordinates, aka domain values, repeated? Well, let's pick a domain value and see what happens. I'm going to choose the domain value. No, it's kind of hard to see, but I'm going to choose the domain value of -6. So at -6, what are my range values? Well, I have a point up here. Looks like that point would be -6, +5. At the same domain value of -6, I also have a point down here at -6, -5. So what does this mean in terms of our definition of a function? Well, we know that x values can't be paired with more than one y value, but this x value of -6 is paired with more than one y value. It's paired with the y value of 5 and -5. Let's choose a different x value and see what else happens. If I choose the x value of -10, I have a point up here and a point down here. Again, I have two y values for my one x value of -10. Same thing if I chose the x value of -2. I have two y values for my x value of -10. What we start to see is a pattern that every time we have more than one y value for a given x value, we form a vertical line. And that's where we are able to tell whether or not a graph is a function with a vertical line, which is where the vertical line test gets its name. Because if a vertical line can intersect the graph of an equation more than once, then the equation is not a function. So let's go ahead and take a look at a couple more examples to see if we can tell whether or not a graph is a function. So we're going to flip to the next page. So we want to be able to tell whether these graphs either pass or fail the vertical line test. If it passes the vertical line test, then it is a function. If it fails the vertical line test, it is not a function. So what we're going to do is imagine that we draw vertical lines all throughout these pictures of graphs. So as we can see in this picture, it doesn't matter where we draw the vertical line. The vertical line is only intersecting the curvy line once. Since it only intersects the curvy line once, then this passes the vertical line test, so this would be a function. So we say VLT for vertical line test. What do you think about the next example? If you draw vertical lines, will this intersect the graph more than once? The answer is no. Every time we draw a vertical line, it only intersects the graph at one point. So that means this is a function, passes the vertical line test. How about the next example? If you draw a vertical line, will it hit your graph, your curvy line, more than once? That's a big yes, which means is this a function? That's a big no. This fails the vertical line test. How about this last example? You're right. This is a function because it passes the vertical line test. Okay, so now that we've learned all about what qualifies a relation or a graph as a function, you're going to learn a little bit more about function notation with a really fun message from Mr. Dahl. Go ahead, Mr. Dahl, and take it away.